All right. So even though it is 8, I think I'll wait another 5 or so minutes before I start the lecture. All right, so I just checked and yes, so next Monday, the 9th, is going to be a holiday because of Thanksgiving public holiday. Okay. So yeah, after today, our next lecture is going to be on Tuesday. But we will have a student support workshop today from, let me actually just double check that, what time that'll be held. Uh, right, so the student support workshop will be today from 3 to 5, and then we'll be having open office hours from 5 to 7. It's just the same link that you used to join this call. All right, so without further ado, let's get started. All right, so I'm going to share my screen. Everyone, let me know if my screen is being shared. Okay, awesome. Yeah, so today we're gonna have this lecture till 10, and then we're gonna have a lab from 10 to 12, and then we have a extended break from I believe 1 to 3 or 12 to 3. Yeah. Okay, awesome. All right. So what I thought I would do is, so today we're just going to be reviewing some of the concepts we covered this week, mostly related to functions, as well as a little bit of an extension on functions. If you have any questions about the course itself or like support related stuff, feel free to email this email. And if you have any questions about like lecture or lab material or any input on how I might improve these lectures, feel free to give me feedback at this email. All right. So first thing I wanted to do was just to very briefly go over this concept of functions and what we mean when we talk about functions. So exactly, yeah. So there will be a little bit of a review on functions, and we'll also be talking about functions quite a bit more. So functions in general, how we're treating them are as like sort of like boxes where we put an input in, something happens, and then we get the output that we want. So I'd say, just behind the scenes of the code, this is a good way to think about functions. Now, fortunately, we can decide what happens in this space inside, right? Like this is the code that we write. We're taking in an input and then we're doing something to it here with our code to get the output that we want. And we compartmentalize all of that inside a function rather than having the code just being explicitly written. And that just makes it easier for us to read the code and to debug and so on. All right, so we have talked a bit about functions. We've had you do functions on your labs and refactor. But I thought a good practice that I have learned is to always write comments. And more specifically, these 3 comments that I put down before every function that I write, usually. And it's like requires, affects, and returns. So the first sentence, I would just write requires and I'd say, I would answer the question, what do we need to input, right? So what are we inputting into this function in terms of parameters, but also what data types is this taking in? The effects, then I'd have effects. So what does the function actually do? And then at the end, I'd write return. What do we return? Both, data type, parameter. It can be, but sometimes it's actually very helpful because functions can get very complicated. And so it's useful to know sort of what do I need to input into this function? What is the intended purpose of the function and what are we returning? So it can get boring, but comments are really helpful. Yeah. especially when you're reading someone else's code. It's yeah. All right. So I thought I would. Oh, no worries. Yeah, you can often write a little bit long, but sometimes shorthand is good. So I thought we'll do some practice questions here where we're gonna take this and we're gonna write it here. So what I will do, I just have an example there. And yeah, feel free in the chat just to share what are the answers to these questions for this function. So let's think about this function. Oops. Let's think about this function in particular. Maybe I'll just keep it as red. So what do y'all think the input is just based on what this is doing? Square. Exactly. So it takes a number. Perfect. And I mean, even the name of the function is sort of a hit, right? So the input is a number, but how many numbers is it taking in? How many parameters is it taking in? Exactly. It's taking in one because it's just taking in A. So it requires a number A, right? So A is our number, is our parameter that's going in. All right, perfect. Now, what does this do? Exactly. So it multiplies the input by itself. That's a good description. So multiplies, I guess say the input by itself. And instead of saying input's good, but I'll say A by itself, the parameter A. And returns, what are we returning? Both, I guess in terms of like the multiplication, but also what data type, right? So we return a number, that's the data type. And what's the nature of that number in relation to the input A, right? Or another term, what's another good way of saying A times A? Exactly. So we're saying returns the number A squared. Exactly. So this is, even if you didn't see this thing, this sort of tells you how many parameters you want to pass into a function, what the function needs to do, and then what the function's returning. So it sort of gives us like a blueprint for even writing the function ourselves, but also knowing what to look for in this function. So that's usually how this is helpful. All right, let's do two more. There's two more here. All right, so what's the requires here? It's a little bit different than before. And I think the hint is in the function itself and what that looks like it's doing. Exactly. So it is a string s as input. No, I don't mean like s the string, but I mean like, okay, I'll just do s uh, string. I'll just say parameter s, and here I'll also say parameter like as in terms of argument a. Okay, awesome. So what does this do? What is this going to do to the string that we have added? Right. So it concatenates it. Actually, let me just double check. This is interesting. So strings, so in JavaScript, once you create strings, you actually cannot modify them. So let's see actually what this is doing is locally it's creating a copy of what we've passed in, and it adds hello to that copy, and it returns that copy. But like if we if we did this, and I will show you this, and this will be kind of interesting. If we did this, let s equals t, so let's just say John. So John is my string, and then if I call add hello s, and then I want to console log s here. What does everyone think? What would this console log be? Yeah, it's just John. Because even though I'm adding hello and I'm passing in a string, strings are not mutable. So that what that means is that you cannot actually explicitly you change strings. I would have to reassign the string to the output of add hello. Because this function is just returning s plus hello, like this s that I pass in, this is going to be a copy of this string. And it's just going to return that to the caller. And in this case, I'm not doing anything with the return value. So nothing actually changes. Exactly. That's a good, perfect. So that's one thing we can do. We can do this. And that'll actually, it won't change the string, but it'll make sure we're returning what we want. However, if I do this, then I can do that and I will get the string I want. So that's good. I will just say as effects adds hello to a copy of s locally. You know, sometimes you don't even need to specify that. You can just say adds hello to the end of the string. And it's sort of understood that this is a copy you're creating. And then here we can say returns the new string. Add hello equals hello. So this will concatenate with hello. But the thing is, this s that has John in it, right? This s that I pass in, when I get to this function, how JavaScript handles this is that this John that I pass in is actually a copy of the John that exists here. It's not the same John like string. It's an exact copy of it. And so to that copy, I add hello. And I return s plus hello. But I'm not changing the original string. Unless if I explicitly say here that I want to return the string from that function and I want to set the return value to s. But if I don't do this, that doesn't happen. So I can actually run this in code here and just clarify that. So let's do that. Let's just call it x. Let's do John. And then let's have a function add hello. And we're going to take in a string. And we're going to return s plus hello. All right. So let's do that. And let's call add hello. Let's pass in John. And let's console log x. Oops, I think I'm in the wrong. Okay, yeah. So as you can see, yeah, it's still John. Okay, here, I can zoom in. How's that? So this will still be John because the return value for this thing, I'm not doing anything with it. And then this S here is a copy of what I pass in. It's not the same variable. It's a copy of it. It's the copy that's being changed. And then as soon as the function's done, that copy is lost. Nothing has been done with that copy. But if I do this, so now this returns a string, a copy of the string John plus hello, and then this value, I'm reassigning it to the variable x. So x is being updated by the return value of that function. And so when I run this, now I get John hello because I'm updating that. So I hope that clarifies things a bit. I will need to zoom out because some of the stuff I'll be doing will involve doing a few things there. All right, awesome. Okay. So, okay, this is going to be interesting. So this is a little bit more complicated, but this is very similar. So now we have kind of weird, what is this? What's going on here? We haven't even named the function, and there's something weird going on. So yeah, I think this is a good exercise. Let's first think about this. What is the input? And you don't need to know much about what this function is doing to know what the input is, just based on how we're treating, you know, A and B. Good. So the input requires two parameters, A and B. And what's true about what type of data type do we have for these parameters? Just based on how we're sort of treating it. Perfect. So two parameters, numbers. Excellent. Okay. Let's worry about the effects later. Let's think about what are we returning? In terms of the how many things we're returning and what type of data are we returning? Yeah. So we're returning number. We are returning. So I would say I would put one number, num. Exactly. All right, let's think about what this is doing. So I'll give you a hint. It's a very long way of writing times something. Exactly. So I'm adding b to itself, and then how many times am I doing this? From 1 to a, including a. I mean, it could be once if a is 1, but here's a good example. If a is like 2, let's say a is 2, and let's say b was 6 when I pass this in. So we're going to run, we can do a little table here. So we can say I less than or equal to 2, I plus plus. So I starts as 1. 1 is less than or equal to 2. Okay. And then we have 2. 2. 2 is less than or equal to 2. Okay. We have 3. 3. Not good. So we run twice, and we're adding this b. We're adding that to 0 twice. And what's the outcome of that? 0 plus 6 plus 6. That's essentially what this is doing, right? Because we're running our loop twice, and every time we run the loop, we add 6. Exactly. So num will be 6, and then it's 12. So it's kind of the same as doing 6 times 2 or a times b. So we're really just multiplying through a loop, multiplies a by b. And I'll just put a times b. Num, the product of a and b. Just move that up there. So it was just a different way of doing multiplication. And then, yeah, what might be a good name for our function instead of having just this these question marks. The question marks were just to hide the what it was doing in this example. Times multiply. All right, yeah, let's do that. We'll put multiply. Multiply, or maybe multiply by loop. Let's call it that. I'm multiplying by using a loop, which is adding. Even multiply by adding. Okay, perfect. All right, so let us. All right, so now I just want to do a very quick review of the example we saw yesterday, which was yeah, problem solving can be challenging, and I do think this approach I remember when I first started programming for like even now I still do this. It's a very good practice to have this, and it helps a lot in approaching the function and sort of being able to break down what it's doing. And even when reading other people's code, it helps a lot to have these here. And even especially comments inside, like short comments that might be saying what bits of code is doing, that's also helpful. All right, so what I'm going to do now is I'm going to do a bit of a review of one of the topics we covered last lecture. So that was functions as objects. And so I remember we talked about a multiplier example, if I remember correctly. So I'll write it out here, and then what I'll also do is I'll write it in the code terminal. Actually, I think I should first just do it in the terminal because it'll essentially be the same. So let's do that. So the idea behind functions as objects is that what we wanted to do was we want to give the user some tool to be able to, let's just say, control functions a little bit better. And so in this example, I remember we created a multiplier function and we had y, right? And then we were returning some other function, x, and then in this function, we're returning x times y. So the idea here is that if we call multiply, we can pass in something as y, a number, and what we return from this function is actually another function that takes in some input x, which we have not specified yet, but we return a function that takes in some input x, and then inside that function is going to calculate x times y, more specifically the y that we have put in when we call multiply, and it's going to return the product of these two things. So let's actually do an example. So I remember seeing this example, double, and then we said, okay, so let's say we say let double equals multiplier, and let's say 2. So what's happening here internally is this. So when we call this, we're going to say double equals multiplier 2. Multiplier 2 returns this value. So what happens is that we say we're essentially saying double equals function x return x times 2. This is like its own function. And when we do this, we're storing that function inside of double. I hope that is clear. And let me do that. And I will actually show this in the debugger that why that's happening and like what that looks like. So let's actually do this. And I'm going to put another line here. Let me just console log double. That'll be interesting exercise. Okay. So let's run this. Let's see what this looks like inside. Interesting. Wait, let me do that and let's rerun this. All right, so these are from, I think the watch, it stores that. Okay, so check this out. So notice how by the time I get here, I already have this multiplier function in my memory. So notice, you see this multiplier, it says f multiplier y. That's the function multiplier. So don't worry too much about some of this other stuff, but just this idea. And check this out. So this is actually saying, oops, what is inside this function. And it says return function x. It's a function with another function inside of it. All right, what is double when we finish this? So, whoops. Double is now a function. And more specifically, it's returning x times y, where, and let me see, where y here is 2. I'm just like sort of going through these just to show exactly, right? So notice how y is now 2. Yeah, so like just like this, because we passed in multiplier 2, we return a function of x times 2. Over here it says x times y, because that is how we created this function, x times y. But here, inside this function, it has y stored as 2. Not the same value of x. So x is not 2. X is just like a variable right now. It's just an argument. We will, if we call this, we will need to specify what x is. But I'm just saying here that this is essentially what, at this point in time, when we have, after we say let double equals multiplier 2, this is what it looks like internally. Double equals function of x, return x times 2. And so double is, the name double is sort of faithful to what this is, because we're returning whatever we pass it, like whatever x is, because double is a function x equals this. This function is stored in double, and the function basically takes x and it returns x times 2, which makes sense. Sort of, it fits with the term double. And so now I'm going to close that debugger. Let's see what happens if I console log double of 6. So what does everybody think this is gonna print if I do this, if I write double of 6? Right, and it's 12 because I have a function now stored into double that takes this 6. Like I'm actually allowed to now do this, because writing this is the same thing as writing this would be the same thing as writing this, essentially. It would be very similar to writing that, where I would just be running a function right away and returning the value. The value of x, when I write double here, and a 6 like 6 is an argument I'm passing in, that's where it gets the x from. It's this 6 that I pass in as an argument, because this is no different than this now. All right, so if anyone has any other questions. No, it's not the same values as y, because remember, y, I passed in y as 2 when I first called this, right? So when I put in 2 here, I'm returning a function, and in that function, I multiply x by 2. It's like a doubling. I'm returning a doubling function when I call multiplier 2.
I have a question. So do we have to do 2 returns, like the return of the function f of x, Like I thought that was the only return. What about the one that you've written, return x multiplied by y?
Right, that's a good question. So the reason why I write a return here is because I want this function to return a function itself. And of course, in that function, I want that function to be able to return something whenever it's called. So that's why I put this return here, because then um, it's only going to see the first return statement, and it's just going to return this function. That's why it doesn't like return this right away. When I call multiplier here, it's just going to return this function to the back to the caller. So then this function gets stored into double.
Oh, okay.
Exactly. Yeah, Oliver. That's an excellent way of looking at it. Exactly. So I have assigned. It's like I've assigned a function to a variable, and then I can just do this. Like I can treat this like a variable and just pass it an argument, and it'll treat it like that. Yeah. All right, so I'm going to continue because I think there are some very important things to get to. But if anyone has any questions, do feel free. I mean, during the lab, I can totally go over this again in a lot more detail. All right, so what comes next? And yeah, I'm gonna erase this for now, but I will be sort of making notes of everything that we covered, and I'll be putting that up on Canvas during the lunch break. So I think this was good. We covered this. All right, so now a little bit of a detour. I want to talk a little bit about packages and modules because this has come up occasionally, and I think it's also really useful to, I mean, you might be thinking, what if I want to put code in other files, right? Especially as code gets longer, I want to have some functions in another file somewhere, and I want to then import those into my main file, which I run and where I use those functions, just so I can hide code in different places, and I don't need to have everything in one file. So this is how we do it. And before we get to that, I thought I would just very briefly talk about the node package manager and like what does it mean to run this command, right? Because we've often been doing this. So yeah, let's do that. So I've made this dummy folder and I'm gonna go into it and I'm just gonna install prompt sync. And I'm not actually gonna use it, but I'm just using this command to very quickly make a package.json. So there are other ways to make that. I'm just using that to very quickly install package.json. Okay, let me just copy this. All right, so there's a command we use called npm init. And so npm, this is our node package manager. So npm, this node package manager, it's a tool that comes with Node. And through this, we can use this tool to access a lot of libraries and tools that other people can actually make, and we can install these. So when I did npm install prompt sync, I'm basically like telling this package manager, I want to install prompt sync because someone actually built this prompt sync, this library that lets us take in user prompts. And so this sort of tool gives us access to that. If I type in npm init, what I'm going to do, and I'll actually show this, is I'm going to create something called a package.json. And the package.json, it specifies some information about our project. So it specifies things like what libraries are we using? And you know what? I will actually, let me delete these and I'll redo that. I'll redo the install. It'll be a little bit clearer once I install this. So this will create something called a package.json. And so that specifies things like what packages do we have installed, like prompt sync, you know, the name of the author of the project, things like licensing. And there's something also called scripts. So we will add commands that we can use as shorthand to run different parts of our program and do things other than running, like deploying. You know, there's a lot more that can be done. Because so far we've just shown you like to run this, you just type node, you have node in the file, but there's a lot more that can be done. So I will do that. I'll do npm init. Package name. Okay, we'll ignore that. Version, description, my package manager uh, file. Let's just say details. Entry point. Okay, so we'll ignore that. We'll ignore that. Say my name. MIT, let's just say, I think that's the open license. Okay, perfect. So when I create this, this just gives me some data about my project. Now check this out. If I install prompt sync, now that I have this, see this out? So now it says this, I have a new entry here, dependencies, and I have prompt sync inside. So this is where it would list dependencies that I have for my project. And the reason why we have this is because, usually these node module files are very large. So when we share projects, we don't share node modules. We just share this package.json. And so then that keeps track of what packages people have installed. And so on their end, someone can they run a command called npm install, and that'll install all of these locally on their end. We don't need to worry about uploading this node modules file. So that's just good to know. For sure. And actually, I will explain scripts right here. So scripts are sort of like a shorthand that let us run something. So let's do that. And let's console log something here. I want to run this main.js file, but I don't want to do that. I don't want to type in node main.js. So maybe it's a bit long. So what I can do is I can create a command in this script to run. And so I will create a command. I'll call it start. And in that command, I'm going to type node main.js, which is essentially the same thing that I type if I want to run this in terminal. I'd say don't worry about this test. So that is, or actually, maybe we can actually run that and see what happens. But so now to run that script, I would need to write npm start. And notice here it specifies the name and version of my package.json that it's actually running the script from, and then this line main.js, and then hello. So I hope that's clear. It's just sort of like a shorthand to write it. It will become more important later when we actually have full stack applications and we want to run, let's say we want to run our front end, which will sort of build the web from on the client side, it'll create maybe like an application with some interesting designs and so on. And then we want to run our server with a separate command. We want to start both of those we have two commands, or we have one command that does both, and so on. Exactly. It's shorthand for built-in commands. And there's a lot, this gives us a lot of power. Like we can even run commands to delete files, to copy files from one place to another. So there's a lot that can be done here. Let's see, if I type npm test, what's that going to do? Perfect. So this echo error test not specified, and then exit. So it gives us an error because I haven't created any tests. For sure, to install. So just to do that, in my directory, I typed npm init, and I just hit enter. And when I did that, let's see, will it redo that? Yeah, so now it tells me, it walks us through creating a package.json. And then it will ask a bunch of questions about, what's the name of this package, what's the version, and so on. All right. So with that out of the way, I want to talk a little bit about using our own modules, like creating our own modules, and what a good use case for actually doing that. So we install package.json. So if you just outright install a library, you might have noticed that it will create a file for us, like package.json. But we install that just to manage our project a bit better. The usefulness of it will is something that'll come up later as our projects get more complicated, and we want to like give very specific shorthand to run a bunch of things or to keep track of all the packages in our file in our project. If we have more than one, maybe we have like 50 packages, right? So there'll be a lot of, oh no, you don't need to install it. I was just doing it just to show sort of the use case for it. Yeah,
Can you show
perfect.
can you show the npm init that you modified? I just want to see where you put the scripts, the package.json.
Yeah, so it's just in here.
Okay.
Yeah, so I think wherever you have installed and like the prompt sync, you will have a package.json, but it'll be missing all of this. I think it'll only have this just because it was not like when you created it, you did not, I don't think we actually showed you how to create this from scratch and then download the packages. We just sort of had the install, and then if you install a dependency or a package outright without having this JSON, it will just create something with this. Oh, you have all of it. Okay, that's good. It's not necessary right now, but when it is needed, we will go into sort of how to start this off. But this is just to show the idea that we have this here, and that this is one way we can use it, and the usefulness of it in the context of keeping track of our packages. Yeah. What does main indicate in package.json? Interesting. Okay, that's a good question. So main, it would have probably been better if I named this index. Oh, thank you. So main is the entry point of our code. It's just like what is the initial file that we might run to get everything going. So that's the idea for main. It's the entry point for our project. So because I said here it was index.js, it's probably better practice that I change the name of this file to index.js. So it's a little bit more consistent. But yeah. All right. So I think now a good thing to talk about would be to discuss, making our own modules and imports. So I'm going to go in lecture 26. I have another main here. And let's say I have a function and I'm going to call this square. It's going to take in one number and it's going to return that number times itself. And let's say I have over here, I'm going to say let x equals 3. And I want to the square of 3. So what's this going to output? I think this is should be straightforward. Let's see, node main .js, right? So this will console log 9. All right, and so this is really a simple example, but what I want to do basically is I want to, now I'm thinking maybe I have a bunch of other functions that do things like square or add and so on. And so let me put a few more here. Function square. Let's say add AB, A plus B, right? Ten, add 3 and 10. But let's say one issue I have with this is, oh, you know what? I should do this. That's much better. Let's say one issue I have with this is I don't want these functions here. I want these functions somewhere else. And I don't want to have to worry about, you know, seeing these here. Maybe there's some other place I can put them, some other file. So one thing we can do is, and I just is we can create a modules directory, or you can name this anything. But the idea is that we want to take these and I want to put them somewhere else without losing this functionality. If I do that. So now it's like, how do I actually over here, how do I get access to these functions? And so there's a couple ways to do it. But one thing I'm going to do is I'm going to show just the generic, there's a built-in way in Node that we can use without actually having to do anything special. So what I can do is in the file that I want to store these functions, I can export them. And so this is the syntax that we use to specify that. I would write export modules equals square and then add. Statement expected. Interesting. Okay, wait, there might be. Let me just double check this. Oh, my bad. I got those mixed up a bit. So it's modules.export. It's not export.modules. So in the file that I want to export these from, I would write modules.export. And then in these curly braces, I just have all the functions that I want to export. Now I'm pretty sure I could just do that. But if I want to have multiple functions, or even if it's just one, it's good practice. You want to use curly braces. So now from this file, I'm exporting two functions. And now what I would do here, oops, in the file that I want to import from, I could write constant. And then, let's say I want to import both of them, square add. And again, I would use those curly braces. And I would say this equals, and this is going to require, now we'll specify the directory. So that would be dot, so this is a relative path. Exactly, yeah, you can have all your functions in one file and then just import them. As long as you give it the right path and are sort of doing it correctly, it can work, yeah. So here I'm giving a relative path. So what I'm doing here is I'm just saying, okay, in the same directory, right? Because modules is inside lecture 26, I have modules and then I have lecture 26 and main. So inside of here, so same directory, I'm going to go into modules and then math.js. So that's actually where it's going to get it from. And let's hope this works. Ooh, what's happening? Modules is not defined. Sometimes you'll get some weird things like this. Let me just double check because I did this not too long ago. Let me see if I am math.js, and here I have module. Oh wait, I think see, the syntax is very important. It's module.export, not modules. And I guess you can see it will color that distinctly. This should run now. Just clear that and run that. Square is not a function. Interesting. Square here. Oh, okay, check this out. I'm importing it. See, like I didn't actually spell, did I spell it right? No, I don't think I did. Wait. If I missed that, I'll try that again. Sorry about that. Huh. Let me just check. I wonder if it's just both or if it's just one of them. Interesting. So it is both of them. All right. You know what? There could be something I am not doing right. So what I'll do just for now, just so the sort of gets the concept across, it is sometimes quite tricky working with that and getting it working. So I do have a working example where I did do this properly. Sorry about that. Yeah, so there is an import command. So here it is working properly. I think there might have been something in what I was exporting or what I was importing. Something quite weird might have been happening. I will have to look into that. Square.
Module.exports, it's exports with the plural, the one that is working in yours.
Oh, okay. Okay, thank you. Thank you. So as you can see, the names are very important. So we'll go back to the, thanks for noticing that. All right, so we'll go back to our lecture 26 file. And yeah, so I also missed that. So this is module.export. So there's an S. Interesting. That was still S. All right, so now that should work. And now if you run this, right, so now we get 9 and 13. So now it's working. So it's very important to have to be very clear with these, to not make any mistakes when writing these out. So that's one way to do it. There is another way to do it where you can actually, let me see if this will work. So, and I will actually go here. Okay. Another way to do it is that we can create a package.json. So it's a sort of a different syntax. So we could specify that we are using modules. And then what we would do is over here, we would change this. And I hope I don't make a mistake here. We would change this to export. This is just another way. Exactly, yeah, it's very common to download functions that do things for us. So that's one reason why we wanted to sort of go in a little bit into package.json. This is just another way of doing it. As long as I have this and I say type module. So I could say export square add, and then over here, instead of doing this, I would say import square add from, and then I would specify directory. And I hope I didn't make some sort of spelling mistake here. It's just perfect. So these are two ways of doing it. The first way that I showed you was using imports, using the requires, and then this is using imports here, whereas before we had requires. So we often use requires server side. So sort of they both have their costs and benefits, but usually requires is used service side, while the import that I've written this way is used client side or on the browser. So they both have their positives and negatives, but we can go more into, when we get to using these more often, we'll go more into details about like when you might use one or the other and in what circumstances it might be better. So with that being covered, does anyone have any questions about that, sort of what we did here?
Please, can you go back to this one, I just wanted to. And what about the modules? How did you create the module directory?
Oh, I just created a folder called modules, and I just put the math inside of that.
Okay, because the icon is different from the others, so it just automatically changes the icon to any module directory.
It might not. I have an extension that just adds this icons.
Oh, okay, okay, okay,
Yeah,
okay,
yeah, but it'll still work. It doesn't need to have the icon. Yeah.
okay, okay.
All right. So both files, same package too. Right. So here, like I want both my functions to be in the same file where I'm exporting them from, if that was the question.
No, that was no. I was just asking about the module directory or the icon about that, and I just want to see the command that you wrote about where you've replaced the require.
Yeah, so this is just a different way of doing it. But if I do it this way, remember, I need a package.json and I need to, in my, like the root where I have main, I guess where I'm running things from, and I need to say, I need to have this here so it will actually run it. Yeah. Estra, feel free to unmute and just and ask your question. I'm sorry, I didn't understand it from the chat.
Right, so do the file that you are exporting from the function have to be the same in the same package as the file you are exporting from it?
Sorry, can you repeat that?
So you have two files that
Right.
you
So
one of them having the functions and the other is where you want to export them to, right?
right. So this file, I have my functions and I export them. And in this one, that is in a different sort of directory here. It's in lecture and that one's in modules. Over here, and I'm importing these from this path.
Okay, so they are not in the same folder.
No. And that's actually the benefit of this is that if they are in the same folder, you don't need any of this. You can just write import from. You don't need to do any export management or anything. I'm fairly sure because I'm I'm fairly sure our when the code executes, like it will know, it can look into the same sort of directory and it can find it. But the fact that these are in a different folder is part of the reason why we're actually doing it this way.
Okay, yeah, thank you.
No worries. All right, so with that being covered, I think we can we'll take a 5-minute break and then we come back. We're going to talk about callback functions. Oh, you can import everything. And it's also in this different directory. Interesting. So it might be smart enough to know to look into that as well. But there are other cases where when it's quite far from where we are running the code, like it's in some sort of nested folder structure, then that's the case where it might not know that. It might not be able to find it. All right, so we're going to take a 5-minute break and then we'll get back. We'll come back and we'll talk about callback functions, and then we're going to talk about recursion. So we'll be back in 5 minutes. All right, so we are back. Let me just check my audio. Can everyone hear me? All right. Okay, perfect. All right, so what we're going to do is we're going to talk about callback functions. And this is a bit of an extension on what we talked about earlier. So what I will do is I will just share my screen. All right, can everyone see my screen? Okay, perfect. So we're going to introduce this idea of callback functions. So this is when and I'm going to introduce this first as functions that we can put as inputs to other functions. And so let's think about an example of a discount service. So, we want to have a function apply discount. It takes in a price and it takes in a discount function. And it'll apply the discount function that we pass in to the price. There might be a better way of doing this, but this is just the example that we have just to show this concept. So let's first do this. Let's make this apply discount function. So we're going to take in a price and we're actually going to take in our discount function. And we will return price. So this discount function is any function that we pass in to this function. We're going to return the output of passing in price to that function. So this will be evaluated. We're going to return the outcome of this. So let's define some discount functions that we could use. So let's say maybe we have a flat discount. And in that case, let's return the price times 0.9. So what we're doing is we're doing a 10% discount on a price for a flat discount. So this is, I know I don't have my requires, effects, and returns clause, but we'll ignore that for now. All right, let's say we also have a seasonal discount. So maybe it's Christmas and we have a special sale being offered. So that is 25% off. So I'm gonna do times 0.75. And then, a flat discount, I think 5%. It'll be 5% off. 10% is a bit much. And then we'll have a special discount. So this is gonna be an employee discount. I will even actually name this employee discount. And let's say this is going to be 10% off. All right. So each of these functions that I've declared here, all these functions do is take in a price and they return a price times some sort of decimal that is going to be the discounted price. And what this does is we take in price and we take in our discount function. So we're treating our discount function as a parameter that we can pass in to this sort of function that applies discounts. And then we return that discount function with price passed in. So I'll show an example here. So let's call apply discount. Let's say the price is $50. And I'm going to pass employee discount into that as an argument. So let's see how this works. So let me, even I want to say let new price, I'm going to say that is equal to that. Yeah, if anyone has any questions, feel free to raise your hand and I'll get to those.
Something that I like to do a lot is I like to play on the computer. So
someone is unmuted.
Put someone on the computer. Another thing I like to do is create something.
Okay, so I'm just going to mute them. So let's put some breakpoints. Exact. So in the apply function, it's going to get the function's returns as parameters. Sorry, could you yeah, feel free to unmute yourself and ask a question. I'll try to answer that.
So the value returned from the discount function is going to be as the parameter of the function apply discount.
No, so this parameter is a function. And then what I return is a call to that function with this price passed in. So I'm gonna do some of this here. I'm actually gonna put breakpoints so we can see this, how it runs. So let's see what happens here. So, right, so all these functions I've declared, perfect. So I have my new price is undefined right now because nothing has been returned. It's just basically an empty value. Notice here, so when I pass in employee discount, interesting. Oh wait, my bad. I should rerun this. I forgot to put breakpoints here, so it's not as clear. These, okay, that should be good. Let's rerun that. I'm calling him apply discount, and I'm passing in 50 and employee discount. And see here, this is just like the very similar to the previous example. Employee discount is a function. All right, so I call this, where do we go? So we go into apply discount and we're returning our discount function and a price. Now I put an employee discount. So notice here that locally our discount function is employee discount. So these are the parameters it's taking in. It's taking in this, specifically this function. Now this here, discount function, I just gave that as a name. I could put Y in there and it would not matter. I could put any variable name in here. I could put Y, I could put X, but as long as so this is actually what I'm passing in to be stored there. And that's why here, that's discount function. And that's my discount function. And then my price is 50. I'm returning that call. So now it should go here to employee discount, which is what I've actually passed in.
So the discount function is not a function.
No. The discount function is a function, yeah. So this is just this is a parameter. The name is discount function, but I'm passing in a function as a parameter. Yeah. So then I go to employee discount and then I return this price back. So now that's 45. Just to make it clear, maybe I can just put Y there. This will still work if I put Y in. So I call that. And now notice again, I'm calling apply discount. I'm passing in this as a second argument. 50 is going to be price, and then I'm passing in a function as a second argument Y. And here it's also like Y and then employee discount. This is the function that I passed in as an argument. So I return that. Oh, what's going on there? Let me rerun that. I think I pressed something, which is why. Yep. That's weird. Why is that? Oh, you know why it's not working? I need to change that to Y. Yeah, exactly. Good catch. Because before I had discount function, so that was fine. But now because Y is storing that function, I need to change that to Y. So that should work now. So now notice, so I go here, I went into this function and I'm returning Y and price. And again, here, Y is employee discount. So now it should go to employee discount, perfect. And then my new price is 45. and then that's how. So that's the full sort of execution, and that's what it looks like internally when it does that. Does anyone have any questions about that? So the point of line 6 is that what we're trying to do is we want to.
I have one question, Alim.
Yeah.
If I did not pass the function name, like the first function that you define, the function you're gonna call it y, let's say. If I did not call it and I just return it, it's gonna be the same, like the same situation that you show it to us in the morning. I should create a variable to call that function.
Sorry, I don't understand your question.
Like now, y, it's the function that you want to call it, right?
So y is, I'm not calling the function y. I'm calling whatever is stored in y.
Yes.
It's the same thing as the double thing.
But it should be a method because you passed a variable to it, right?
I passed a function as a parameter. So it's treating this as, like I'm treating this as a method where I can, or as a function where I can where I can pass the price into it, because over here, I know that into y, I'm passing a function, this function.
Yeah,
So
but
that's why I do it that way.
But in the morning, you did not pass it in the parameter, the function, but you return it in the content of the function, right? Like you return function whatever x something, right?
Right, because yes, but that is actually that's very similar, because the double was storing a function. I guess, yeah, that's a good way to think of it, that this y is sort of like storing a function inside of it. It's very similar to the example where we had double and then like 2, or I guess that was 6 was passed into that. Yeah, it's very similar to that.
Okay.
Yeah, no worries. Also, I see another question here. Yeah, I just changed it to y just to show that it's sort of independent of what parameter we pass in. Yeah. Also in future, just it makes it easier for me to keep track of like who's asking, and if I'm sort of responding to a question in chat or on or by voice. So just if anyone does have questions, please do raise your hand. All right. Yeah. Yes, Hannah.
I have another question for the function that we pass it as a parameter. You did not pass any input for it, so it should taking the same input for the main function, like one input. You know what I mean?
So over here I've defined, so over here I've defined this takes in one input, and then I specify that here, because I'm just passing, it's very similar to that other example. This is just so this parameter is going to be the function, so it has the function inside of it. And here, so this is price is what I'm passing into the function that is in this y. Let me actually run the debugger again, just to see.
Yeah, I got it, but my question, should always let's say the sub function that we pass it to the main function should always take the same parameter that the main function take it once I created? You know what I mean? Like here, let's say the apply discount take 2 parameters, the price and the y. We're gonna replace it with the function that we call it. Okay, for the flat discount, you just pass price, because the main already function apply discount, it's taking price, and you just pass the name of the function, so it's by default the price is gonna take it from the main function. But I can't like pass another parameter in the sub function.
Oh, I see what you mean. Right, so could you have something else here, x?
And I should pass it there?
Right. That's a good point. So I would assume if you have something else here, yeah, you would have to pass it in here. So you, in this main function, you might have x, and then let's try that out. So we're gonna have x there, and we're gonna take an x, and then let's say here in, where was it, employee discount, I'm gonna console log x. You would need to, that would have to be very specific behavior for that one, and then I could try this. Let's see, test. It would also depend on which of these you're calling. Like in this case, I know that I want to call this one, which has that argument. So then I need access to, I would need to actually pass it in here. So let's actually try that. Oops. Right, so notice, see here, now it console logs.
Oh, okay, so the parameter for the sub function, I should also pass it as a parameter for the main function. The same.
Exactly, yeah.
Thank you.
All right, so I'm just gonna console log, I'm just gonna comment these out, and then we can get to arrays. All right, so this is actually a very important concept for our lab today. We're going to think about array callbacks. So you might have seen that earlier we were using some methods like array.push, array.pop. You know, arrays also have some other methods, and I'm going to show some of these in the context of callback. So let's say I have an array with 5 values, 1 through 5. And what I'm going to do here is I think one interesting thing we can do. So there is something called for each. We'll go over this. So for each, essentially what this does is it'll accept up to 3 arguments. So, you know, what we would pass into it here, and we're only going to concern ourselves with this value. Let's not worry about this array or index for now. What this does is it lets us get access to the value inside. So we can pass in a function. And I'll just show what the output is of this. It'll look a little bit, oh, whoops, this is not an arrow function. Okay, so let's see, what does this look like? All right, see, so this is a very simple way. In this case, I am just going to be printing out all elements in this array. And what for each does is it can perform some action for each element of the array. And notice here that I am passing in a function. So some function is going to be run for every element in the array. Now, one thing to note is that it does not update these elements. So if I were to say lm equals lm times 2, if I were to try to double these, and then I want to console log this, it should not change. And I will just, yeah. So the array stays the same. So this method, I cannot, at least not with this lm, I cannot update these items, because what's actually going to happen is that this for each returns, well, let's actually see what it returns. Let's see what it returns. I have a feeling it might return a new array, but no, so it doesn't actually return at least anything in this case. So ignore that. But essentially a good way to think of this is that for each can take a function in that lets us do something with every element in the array. Now, if I wanted to explicitly modify these elements, remember that index here? So when I did for each, it even tells us we can put a callback function into this. So this callback function will run for every element in this array, or this is an array of numbers, so every number. The callback function can take up to 3 arguments. Right now, I just have 1 argument, which is the value itself, the first value, the second value, and so on. It can also take the index. So if I just put I here, if I do this, let's see if that actually updates it. That's a let's see what happens. So in this case, now it is actually updating the value. The values in this array, it's doubling each one. So I think the most important takeaway from this is this for each method that's built into arrays. It's essentially a method that we can put in a callback function, our own callback function, and we just get access to up to 3 parameters each time this function runs. So we get access to the value, because this is going to run for each element in this array. We get access to the value, so the element itself, the index of that element, and this array. Now, I'm actually not sure what this array is. So what I'm going to do is I'm going to put X here, and I'm going to console log that X, because I have not used that before. So let's just see what that does. Interesting. What if okay, so see what it's doing? It's exactly, right. So put it before, edit it.
Like cancel it before, like.
Oh, before the update.
Yes, yeah.
Perfect. Okay, let's try that. Before, we'll print out X, and then after. And I think what it is doing is this is just like the array itself, and it's just going to print. We can print it before and after we do that update. And let's see what happens. I should get right. So before it's 1, 2, 3, 4, 5. After it's 2, 2, 3, 4, 5. And so it's just showing the array before and after the update. Now I do want to check. Yeah, I guess this is explicitly referring to the same array. I wonder if that is the intention for having that as a method. Let me just check. If I refer to this, if I call this Z and not the same as X, I want to see if that works. Notice that I use the same variable here that I used to declare the array. So I just want to change that just to see if that's built in. Oops. I think I pressed the wrong command there. So that actually still works. And that I'm not using the same X. So this is my array. I will even make this more explicit. I will write array. So all I'm doing here is this for each function. This for each that's built into arrays, it lets us pass in a callback function that gives us up to 3 parameters. And these are like built-in parameters that it will handle internally. But it's telling us that these parameters can be the value of the array, the value of the element on each call. So 1, 2, 3, and so on. And it'll be the index. So the index, so like value 1, the index at this point is 0. So for each is different from a loop because it actually gives us access to these things in the array while we're running it. The loop, we would have to explicitly sort of get access through using the counter and trying to like doing an index access. What this does is it just gives us outright. And it's also running, I guess another way to think about it is it's running for each element in the array. This function that I'm gonna just highlight here runs for each element inside of this array. So this for each gives us access to the element itself, 1, 2, 3, 4, 5, the index, 0, 1, 2, and so on, and then the array itself that we are working on, which I have referenced as Z. And so that's why when I console log before, here before, so that is before I do the change I'm going to do. The change is array of I, so at index 0, right? Because I'm getting the index from this. What is the index of the current element that I'm looking at? I'm setting that to element times 2. Element, again, I get it from this callback function that's just built in. So that's 2. I set that to 2. I set this to 2. And then I print out the result of that from, again, using Z, which is already defined in this callback that gives us access to the array we're working on. And so that's how I get that. And it's how I change 1 to 2.
But I have, so where does the I start get its initial value? I don't see it initialized anywhere. I don't
We don't
see it.
need to worry
how-
about that because that is built into this callback. So this callback, it just says that we don't need to like initialize anything because it internally it handles these 3 values and it's keeping track of them. Because for each, essentially what this callback does is this for each will call this callback on each element in our array, and it gives us access to up to 3 arguments just internally in this array. The value of the element, the index of this element, and the array itself at that point in time when we call that.
So the index is starting from 0 or 1?
The index always starts from 0.
So, okay.
For sure, yeah. Let me print I. We have this here, and I will say, let's just console log, and I will say that we are updating index, oops. And then what I will also do, I want to put a single line after each update. Let's rerun that. So here, before we have 1, 2, 3, 4, 5, right? And I'm getting the array from the callback. This is just a built-in callback that lets me get those values. That's before. We're updating index 0, which is the I that we start with. And then after we update, we have 2. So maybe let me actually do times 5. So it's a little bit, doubling is a bit weird because some of the numbers, are shared. So let's try that. So before here, we have 1, 2, 3, 4, 5. Again, from the callback function, I get the array itself, which I'm just going to put that as Z here. So before I have that, I'm updating index 0. So that's from this statement here. And that's this array of I equals the element itself, which I get from the callback times 5. And then after, I print it out here, what the change value is. So I guess the idea here is that this is a bit of an extension to callbacks, but I'm just showing that it's called a callback because this thing is called for each it's a callback function because this function is called on each element. And for each will call this function once on each element. And the callback function, it just gives us, internally, it gives us access to some things that we wouldn't otherwise have if we were to just do a for loop. Like we would have to put more complicated code to get it. Like the value itself, if we wanted to get the value, we would actually need to do an array access with a counter to get that. The index we would have for sure, because the index is we would sort of have the index, and the array itself we could have as well. Yeah, but this is a bit of a simpler way, at least what I'm trying to get at, of doing a for loop. You know, another way, I think before I had all of this, I was just console logging the element itself. So I can do that as well. And again, the main takeaway of this for each, I was just showing, you know, its full usefulness. The main takeaway is it just lets us, it's just called on each element of this array. And so now it's called on each element, I'm console logging that, and I get all the outputs. We are updating, and for sure, yeah, we can change the, so if I could do that here, I will just do that quickly and then take some questions. So let's see here. We are updating, and you know what? I will even say, and this, let's store the old value. Actually, the old value is stored in the LM itself. So we are updating LM2 I, right? Because this is going to be the old value, which is the parameter that goes into our callback, just the element itself. And then the new value is the actual, is what we update. So let's see if that works. All right, so now we're updating 1 to 5. We're updating 2 to 10, and so on. Anybody have any questions about this for each? I think the most, don't worry too much about like all this other stuff I'm doing here. That's like trying to take this out to its full functionality. Yep, for each is essentially we can, yeah, exactly. So we can think of that as a function. Yeah, that's a good. And so for each, it takes in a callback function, which is what I have defined here. You know, and here explicitly, I'm just console logging. Now I could also do this. I could also say function print value. And I could say, I could do this. And then here, instead of doing this, now it's more clear that it is a callback because I'm just going to pass in print value. Can I do that? Let me just see if I can. No, so value is not defined. Okay. We might need to, what if I just do this? I'm just going to do that. Okay, so the reason why I can do that, yeah, so I'll upload this on Canvas. So the reason why I cannot, so I have to just put in the value is because now it's treating it like this, right? Where the first, any callback that I put in, it'll treat the first parameter. Yeah, so it doesn't return anything. It just calls itself for every element in the array. For each, whatever I pass in is called for every element in the array. So the reason why, whatever, like now that I'm actually referencing a callback and I don't put value or anything is because the callback that I put in, it'll treat the first parameter is always going to be the element. The second will be the index. The third will be the array. And I think just to clarify that, I will do this. I'll say element is lm at index I. Let's just see that. Right, so now we say element is 1 at index 0, 2 at index 1. So that's another way of writing that. And in this case, now again, because the for each, whatever callback function we get in, it treats it as if it has up to three parameters as inputs. And so first, I was just using value. I was just having the LM itself, and then I was having index. All right, so if that is clear, let me see. There's one more thing I want to talk about. So there's another built-in called map. And this will, so again, it's very similar. It accepts up to 3 arguments. So any function that we put in, we can have up to 3 arguments in this function. And again, it calls the callback function one time for each element. But the only difference is that this will actually return the array itself. So if I do this, if I console log, and let's say I do array.map, and let's just do that. Now, let me just see what that does. So now I'm thinking, okay, for each element in this array, I'm going to double the element, and then it should return the modified array rather than just giving undefined, which is what for each did. Oh, interesting. So it gives us undefined. Oh, okay, here, my bad. You need to return, like in this callback, you'll need to return what you modify. So if I say, maybe I could just do that, return LM times 2. That will need to be done. So now this map is called on each element in this array, 1, 2, and so on. And I'm returning that element times 2. And it creates a new array. So a new array is returned to this console log. That's different than the other array. So I can console log, let's console log our original array. And maybe to make it a bit clearer, I will do times 12. So we can see the difference there. So this is the array I have on map. It's a different array. This is my original array. And so one difference, so in this case, what I was doing is I was modifying an existing array. So that's why it sort of looked the way it did. Map is quite similar, but map expects, I think one key difference is that map expects a return value. And map returns the new array. So let's see what happens. Okay, that's a good question. So let's actually see what happens if you put a return in for each. Just the element itself. If I put return, I'm anticipating that it will not actually complete. It'll not fully complete. Oh, no, it does. So you could put this here as well. But I guess it's not explicitly necessary. It depends on where you put it, I would say. So the only difference is that I guess the array.map creates a new array composed of the values we return inside the function. For sure, I can repeat the difference between both of them. So both of these iterate over arrays, but they're slightly different. So for each iterates over an array, and it performs an action that we specify in this callback for each element in this array. Giving us access to things like the value of that element, the index, and the array itself. But for each does not return a new array. It's always going to return undefined. So we typically use it if we want to do something like, let's say, console log elements, console log the values of this array without returning anything. So map is quite similar. We can also apply a function on each element, but what it lets us do is return a new array. So as we apply these elements, we can sort of think of it like internally we are creating a new array, and that's the array we're returning. And that's also why we need to return. We actually need to here, as you can see, we needed to return whatever we're modifying here. If I just have lm equals lm times 12, that would not work. It was just giving us undefined values for each element in that array. Like if I just did this, the new array that we returned, each value was undefined because it's not being set. So we have to put the return lm, because this thing that we return on each call is what actually goes into our new array, as can be seen there. So I hope that's clear. Does anyone have any questions about the difference between both of these, for each and map? I think a good way to think of it is that for each, both of them are similar in that they let us apply a function to every element. They're different in that for each does not return a new array. And typically we don't modify the array. Now I was modifying it just to show it's possible, but typically it's when we want to do something, but not return a new array. So we want to do something on each element, but not return a new array. Map is also applied to each element in an array, but it creates a new array that we return, as was seen in this console log. And the reason that we actually need a return statement is because in this function that we put as our callback to the .map, we'll specify what we want to do to these values, and we have to return the new changed value. It's usually used in that context for making changes to like all the elements of the array. And so that's why we return here, so that our modified values are in the new array. So I hope that clarifies the difference between map and for each. Does anyone have any other questions? All right, so there's one more, and trust this is the last one, but this is important for our lab. There's one more topic we want to cover, and that is the filter. And that's also a callback. So let's do that up here. And don't worry, I will write this out. I will after this lecture during our break, I will rewrite these notes, a little bit more explanation, and I will show and I'll put examples for use cases for everything we covered today. And I'll get that uploaded on Canvas, as well as the slides. Yeah, no worries. All right, so let's do one more example. We're gonna do filter. And I think a better way to teach filter would just be, let's think of some like random numbers we can put in this array: 10, 29, 16, 13, and 5. Maybe we want to filter this array, like we want to remove values in this array. Let's say we want to remove all values in this array that are less than 15. So how can we do that? So one way we could do that we can have a filter. So filter, this is very similar. And again, this method also takes a callback. And the callback can take in the value itself, the index, the array. But the idea is that the callback returns true or false. And so so we can specify what condition we want for essentially for this array for this element to remain in the array. And let's actually make that a little bit clearer here. So let's just worry about the value itself. Let's not worry about index or array right now. So remember I remember saying that if my value is less than 15, I do not want it to be in the array. So we'll make a simple condition. So we'll say if value is less than 15, I want to return false. Otherwise, return true. Now what this does is it's going to say, okay, for each of these values, I'm going to run my filter. If my filter is true, that value will be kept in the array. If it's false, that value will not be kept in the array. Now, one thing to mention is that this returns a new array. So let me just say, let me make that my new array. My new array is going to be stored into Y, because this filter returns a new array, and I'm going to store that into Y. And then I'm going to console log these two. I'm going to say my old array, so we can compare. It's just going to be array. And my new array is just going to be Y. Okay. If I run this, as you can see, so that's how a filter is being done on this. So again, the filter is running for each value, and it's checking if the function returns true on that value, I keep it in my new array. If it's false, I remove it from the new array, or I don't have it there. But this is run for every value in our array. And that's why our old array only has 29 and 16. So it's going to see 10. It's going to be like, okay, 10 is less than 15, so I return false. So that's not going to be in my new array. But 29 returns true, so it is, and so on. And, again, just to relate this to callbacks, I can define my filter. I can even define this here. And I can have this here if value less than 15, return false. Otherwise, I'll just return true. And then instead of having this here, I can just put my filter here. I can define the function somewhere else, and I can do that. So let me say, we'll run this, and then I'll extend it a little bit. Okay, so it still works. I remember mentioning here that our callback function can also take the index. So it'll also tell us the index of the element that we're running on. So I'll put index. And because this is false, I'll just say here, we are removing, so we are removing at index. So let's see what that looks like. So we remove 10 at index 0. Now, okay, so these indexes are actually changing. So let me just do this here. So after we remove 10, so remember 10 is obviously at index 0. When we remove 10, the array looks like this, so that the next time it says we're removing 13 at index 3, that's 0, 1, 2. Oh, okay, actually, never mind. It's a new array, so my bad. So because we are creating a new array, but we're sort of iterating over the old array. So those two things are separate. My apologies. So we're removing 10 at index 0, so that's here. 13 is at index 3, and we remove 5 at index 4. So the only values that stay are 29 and 16. Because again, in this console log, we're not removing those. Does anyone have any questions about filter? I will even, let me actually, for sure. And what I want to do is, regardless of whether we return true or false, actually it would be kind of hard to print out the new array and to show that it's being changing. So I will go back to what we had before, for sure. So the idea behind filter filter and it, so filter has a very specific use case. It's when we want to remove item if the expense is more than the budget limit. So the thing with the expenses tracker though is that it's like before we add some, like we are keeping track of our expenses, and then before we add the item, like as we're adding the item, we sort of know whether it's more or less than the limit. So I guess we could just not add it. It might be easier to do it that way. Because the thing is, if we have like a list of expenses, I'm just thinking, and that list is over the limit, there are any number of items we could remove to put it under that limit. So in the context of expense tracker, because we have access to our budget and we know like that this particular item, if we were to add it, it would exceed that budget, we could just not add it. So we don't need to like, filter is like once everything is added to some budget, then we want to like, or to an array, we want to go over that array and remove individual elements based on our own constraints per element. So like this sort of thing that's in the expenses tracker, that is like that's a constraint that is applying to the whole, to all of the, like to all the expenses in our expenses array. Like the sum of those expenses exceeds our budget. So it's a bit of a different, the domain of the problem itself is a little bit different. So I'm not too familiar with that lab, but at least that was the impression I'm just getting from that lab is that, yeah, is that we want to, yeah, but we can take that up during lab time. So the index parameter, we just have access to it in our callback, right? So it just tells us the index of the current value that we're on. The index, like it's, where is it located in our array that our callback is being executed on over. Right, so for each element in the array, we're running this function myFilter that we pass in, and myFilter gets access to up to three variables. And the first two we're concerning ourselves with. So the value, right? So what is the value of the element that we're currently executing on, and what's the index? So if I were to run it, and it would like, first it's going to look at this 10, right? It's going to first run on the first element. The value is 10 and the index is 0. And then here 29 is the value, the index is 1. So there might not be like, depends on what we want to do. Here I was actually explicitly modifying the array itself. So there was a use case. It really depends on what we want to do with it. Here I thought, a good use for it would have been to just say that we are removing, let's say, the value we're working on, we're going to remove it, and it's at this index. So that's why I'm using it here.
So, my understanding is still not clear in the sense that I understand that we are sending in the array into the filter function, and the filter is basically being called. But then you are checking if the value is less than 15, but there is no, it's just a counsel. Oh, you're returning a false. Oh,
Mhm.
based on the
So
return, it's removing it. And
exactly.
okay, okay.
If the return is false, like that's sort of built into filter, like what the filter does. So we don't need to worry about that. But false is just to tell it that we don't want this element, and true, otherwise we do want this element. So that's how this filter, when it's called on each element, it determines whether this element should or should not be in the new array that we're returning. Yeah, perfect. Okay, so we are going to we're going to take a 10-minute break and then we'll start our lab. So I will get the lab ready. Yeah. So today's schedule is we're going to have sort of this lecture, and then we're going to have our 2-hour lab, and then we'll have an extended break from 12 to 3. And then when we come back from 3 to 5, we have a student success workshop. So it's at this same sort of this same link that you use to enter this lecture. And then we also have open office hours where we can take up questions, especially lab questions from like older labs. We can help with that from 5 to 7 p.m. today. All right, so let's go on our break. We can come back at 10:20, and I will work on. I will get today's lab up, and essentially today's lab is just we're going to be using these sort of callback functions for an example. And what I'll do, yeah, so I'll post the lab up. Yeah. All right, so let's come back at 10:20, and yeah. All right, so I'm just gonna pause the recording, and when we, when questions come up in lab, we can start that again.